Welcome to the last class. I'm again and again claiming it is very important to understand that the real learning of thermodynamics should be with respect to a cyclic device. You may use personally for a small process or a small property calculation, that's okay. But unless you understand the larger perspective of the cycle in which your device or your invention is going to be, your understanding will be minimal. Uh, Another great example is this. All the initial inventions, in fact, I'm a fan of steam power plant. Why? Because this is the one. As an invention, this is the hardware which is the mother of engineering thermodynamics. Maybe it was not a turbine that time, it was a steam engine, but this is the one which changed the lifestyle on the globe and almost encouraged everybody to think about more and more better way. And eventually, this is the hardware this is the application which became the mother of thermodynamics. Within this large power plant, we are looking at a small boundary. And here you see this one. Inside the boundary, there are 4 explicit control volumes, namely the steam generator. This is called a steam generator. This is a control volume. There is no storage in principle here. And this is a turbine, again a flowing. And this is a condenser or a cooler. And this is the pump. All the 4 control volumes are connected that head tail, head tail, the tail of one connected to the head of the other. If I draw a boundary, you see this is the beauty of this one. Nothing crosses the boundary. No mass flow crosses the boundary. Means if I develop a cycle using a control volume, the complete cycle will be control mass. No mass crosses the boundary. What can cross? You can imagine here. The primary expenditure. I am burning coal giving as a heat, or I'm collecting a lot of solar energy, solar thermal power by investing a lot of capital cost giving it to this. I may be digging the well, getting a geothermal fluid and giving this. Or I'm burning a lot of biomass and giving this. These are all resources. I pay for this. In fact, my total expenditure depends upon how much I have to supply here. In fact, my cost is how much heat I am adding. Unfortunately, the people tried hundreds of possibilities. It was a thousands and thousands of effects. And without rejection, they could never get this particular one. How to prove this? The people were spending lifetime. All the Q dot in should be converted. Why should there be a condenser? Why should there be? Unfortunately, it was impossible to have any idea, a cycle, hundreds and thousands of possibilities they did. It was impossible to have, not to have a Q dot out. Not only that, the moment I have to remove the heat from the system, then what should I do? I have to have a large infrastructure. All of you might have visited a steam power plant. There is a big hyperbolic tower. This entire tower is to ensure that Q dot out will happen. And I am looking for an innovation where Q dot out should be zero. That never happened. Over and above, I have to invest a lot of money to make sure that this Q dot out will happen without any problem. If that doesn't, then the entire cycle will stall. A system will stall. Very, very interesting. And the people could not understand a fundamental way of mathematically proving that Q dot out cannot be zero. They have to come up with a kind of a law to enforce people to a better living. Similarly, I'll get in return what I'm getting. I'm getting a huge amount of electric power, mechanical power. But to make the cycle continuously running, in a typical steam power plant, now 2% of this power has to be given to the uh, pump. So that's how if the turbine produces 100 megawatts, around 2 megawatts will go back to the system. That's how the net power I can get will be the only 98 megawatts. And this 98 megawatts is much, much smaller than Q dot E. Why? I had to throw something. And as a first law, you can do algebra of heat transfers, algebra of work transfer, they will be equal. That is a matter of what is the net power coming. But the unfortunate thing is what I pay is not for the net heat transfer, unfortunately. What I pay is for the total heat transfer, Q dot in. I have to burn lot of coal equivalent to Q dot in. I have to capture lot of solar energy equivalent to Q dot n, invest money, maintenance, everything. So this is where the people are conscious about more than what it is. It is easy to depend on the law, how much net power I am getting. And this net power out should be greater than zero because it's a power plant. It's okay. But the question is, to get this particular output, what is the cost incurring to me? Is it okay? Or should I be happy with whatever comes? So just satisfying a first law was not enough for economic development. You imagine, how do I get a cyclic integral? You add the heat transfer in each process. In this case, no, there are two devices only doing a heat transfer. There are two devices who only doing a work transfer. So addition is very easy. What is the unfortunate thing is, I don't earn any money for Q dot out. Nobody is there to buy this Q dot out and pay because you are rejected, I'll buy from you. But I have to incur a cost for a Q dot in. Unfortunately, where I earn money for the net work which I can give it to the grid or a local public or a industry. And out of the turbine output, something has to be spent. So in a way, depending on the first law will help in design, calculating the loads, etc. But to compete the world, and if there are two inventors produce the same steam power plant and same capacity, how do I judge who is doing a better? Same thing happened to the James Watt. James Watt was worked on a Newcomen engine and asked the owner, give me 2 years time and spend some money, I'll give you a better engine. Then that fellow asked, what do you mean by better? I want a 10 liter per day pumping or a 10 liter per hour, it is doing, I don't want bigger. So till the James Watt thought about, nobody knows what is a better quality, better engine. James Watt has to prove a point that there is something beyond a first law for the sake of better production. What is that beyond a first law? How do I come out? You see this one? I can have a turbojet engine. I give lot of work to the compressor and I add a fuel and there will be net power output which is driving the aircraft. So if I put like a cycle, this is the one. It is a systematically open cycle, but again and again I am taking air from the ambient, throwing it to. So I am taking the environment as a cooler or a dumping ground, the pollution ground. So that's how this is making a cycle. Here also, some of the heat has to be rejected. And the again and again people tried, IC engine. If I draw an IC engine, it may be a single control mass. I don't have so many control volumes doing, but I have to burn fuel. I have to reject something, and no doubt I am getting some net power output. Okay, sorry. Now you see the entire thing. So there are hundreds and thousands of ideas. Every idea, there has to be some Q dot out. The Q dot out cannot be zero. Then the people thought ki all my intellectual level, all the intelligence, most modern physics, modern inventions, none of them gave Q dot out zero. So then the people said ki are we wasting our efforts, money, everything to invent something with a Q dot out zero and unnecessarily work for nothing. It's unfortunate because every nation has a fixed earning, fixed money. Waste that money on something impossible is stupid, isn't it? People have to be wise. Every scientist should spend money on an invention wisely, not an arbitrarily. So this demanded a kind of calculation, a kind of approach to. So let me say that performance of a heat engine. Let me understand. I'm producing some capacity as per the first law, no doubt about it. Is that sufficient? Do I have to think more than that? What is that way of thinking? Let me put into together. If I depend on the first law, I know how to produce exactly network output of 10 kilojoules, 100 kilojoules, or net power output of 10 megawatt, 100 megawatt. Is that sufficient? That's what happened. Till the James Watt entered, people were happy to produce a capacity without caring. And later, it took around 60 years for Carnot to think well before designing that I'll get a better thing. You see this one, 200 years people misuse the energy depending on the first law indirectly, though there is no thermodynamics available. You know that. What is important, no? Thinking like a net is not correct way. You need to know how much is input, how much is wasted, how much is the mechanical power generated and out of which how much is internally used. Very important. You need to know diagnosis of the net. Depending on a cyclic integral will not solve the problem for each other. That cyclic integral has to be broken into pieces and you need to know a budgeting where I am paying, where I am losing. Unfortunately, if you see the rule, I pay for this. Though I reject, nobody will pay for me. In fact, now I have to invest more money on managing this waste out of my plant. And I literally produced this much, but unfortunately, I had to use some part internal operation. So all these things have to be done perfectly for the sake of competition. You see this one? A balance sheet is essential. All the heat input is consuming the resource. I pay for it. I pay for a large quantity of heat input. As a result, what I get earning for, I'm earning for only the cyclic integral. What is this nonsense? I pay for the process integral and I earn for cyclic integral. Now, what is the question? How do I maximize the cyclic integral for a given process integral? So, for a given value of this particular one, how to maximize this is the goal of invention. And why I'm not able to do is the first level. So that's where the people wanted to evolve and people wanted to come up with a performance measure which is accepted as what you are paying is a denominator. That is called a cost. What is the benefit you are getting? W net. That the benefit, cost to benefit ratio, how much costing, out of the cost, how much benefit I am getting. The first time in the history of everything, the James Watt introduced a concept, consciousness. It is not enough to produce some power. It is also important to know how much you are paying for that power, how much damage you are doing to the nature, because all the Q dot out is a damage to the nature. You are burning and dumping so much thermal energy onto the air, water and solid waste. All this should be considered as a holistic. Okay, one need to understand, as I said it no, very important. You earn money for a cyclic integral, you are paying money for the process integral. And the process integral is unfortunately much larger than the cyclic integral. And what is the objective of innovation? How do I maximize the cyclic integral for a given process integral or vice versa? For a given cyclic integral, how do I minimize the denominator? And before that, why can't I make the denominator numerator same? Why I am trying my lifetime, why I am not able to have a cyclic integral is equal to process integral? Why it is not happening is a big deal. The people wanted many things. Okay. Similarly, please refer to the notes. I'll give the inverse of this one to the refrigerator, air conditions, etc. Let us go to the most important step for today because I have to close. It's very important. Somebody has to enforce that. Don't make a child play. It's not a child game. You cannot consume the resources. You don't waste for something which is impossible. You need to know, as an intellectual, you should not strive for something by wasting money, time, etc. How to know? Can you believe somebody enforcing a law that you should not do this? It is doing like this is stupidity. A government should not fund a project which is against this law. Very interesting, no? So I think no other science will have such a powerful law enforced on the innovator. I challenge any subject which has such a, that's why I know thermodynamics is a science of a pure invention. Invention by saving the globe. Invention by saving the resources. Invention done economically. Okay, so you need to skip around few slides. Go to 70. I get a 70. Out. Okay. Do you know? I'll do this. So I'm skipping this one. You can always see the entire thing. What is the thing is there are two templates which are the thing. The people were innovating a heat engine. You can say steam engine, steam turbine cycle. gas turbine cycle, IC engine cycle for automobiles, etc., cars, etc. There are many things. But in all the cases, what they found is this is a compulsion. You need to create a high temperature. That high temperature will transfer the heat to your engine cycle, out of which you have to reject. To reject, no, you need to depend upon a low temperature resource. And whenever, if that low temperature research is ambient air, you have to be careful about the nature. Otherwise, what will happen? There will be a situation like a global warming or a ozone layer depletion or many things which are making us to suffer because we did not consciously perhaps done for a long time. Now we are doing. This is the one. No doubt, all your effort will fetch some output. No doubt about it. So the hundreds and thousands and millions maybe of efforts could not make um, Q dot out 0. If the Q dot out 0, I'm not spoiling the environment at all, isn't it? I'm not throwing any dumping anything. It's a great job. Similarly, the people, whoever is interested in the cooling effect, maybe refrigerator, air conditioner, etc., they had to. The heat transfer occurs without any payment from a high temperature to low temperature. But if you want a heat transfer from low temperature to high temperature, you have to pay for it. And anybody who is coming with an idea, spending lifetime spontaneous heat transfer from a low temperature to high temperature, he is wasting government money. He is wasting some tax or anything, or he is wasting his all intelligence. Now how to enforce? How to make the people that don't do these two stupid things? Never aim for. So that's where I always wonder, people had to enforce like a law and not like a logical statements or analytical statements or anything. Conservation of energy looks like a more of a based on some law of nature, but this is a more of a law stating again law of a nature. So this is first parallelly done by a Kelvin and Max Planck. There was some literally difference on one international meet. The Kelvin and Planck agreed together one statement. In the statement, I'm changing a little because I'm conscious about engineering thermodynamics. See the statement. It will be meaning the same. I'm avoiding a statement like a system going in a cycle, etc. A system going in a cycle is nothing but a heat engine. Every heat engine is supposed to be doing a cycle. And every heat engine, when it does a cycle, a system of control volumes will lead to a control mass only. So that's how no ordinary books describe this heat engine with a word. I have explained what is a heat engine through sketches, diagrams, etc. I am using the word. Let me read. It is impossible to construct a heat engine which produces no effect other than the extraction of heat from a single reservoir. It will depend upon a coal mine. It will depend upon a solar energy. It will depend upon a geothermal, but it will not spoil any other. No other thing is required. That is impossible. It has to depend upon two. One resource, one dumping ground or a dumping reservoir. There are two reservoirs it has to depend upon. Then only it can produce the work. And continuous production is very essential. You see, it is impossible to construct a heat engine which produces no effect other than extraction of a heat from a single resource and the production of an equivalent amount of work. Suppose if it is impossible, I want to know, according to this statement, what is possible they want to say. In anybody who is doing research on what is possible according to this, no problem, isn't it? So I want to think inverse of this statement. What do they want to say? What is possible? Give me a whiteboard. So I'm sketching this statement. What they say that you have a source and I'm saying this source as a high temperature reservoir HTR. And you need to depend upon this source. This will give you a continuous heat input. This could be a solar thermal, geothermal, biothermal, yeah, fossil fuel, anything. Then you need to innovate a cycle. The innovating cycle is your brainchild. But You cannot have all the heat transfer becoming a W dot out. I cannot say I don't need any more reservoir. This is impossible. That is what is saying the second law enforcing. Nobody should try for this. Now the question is, if this is impossible, what is possible? What can I try? I can try for this. I can always invent a machine. Okay, I'll say that is also engine or anything, which can take the work input, and all this can be dumped into a Q out. This is possible. Okay, if I wish, I can take a lot of work and convert into heat. Something like you use all the muscle energy to generate the heat. I don't need another reservoir for this at all. This is possible. And what is also possible is obviously this one. That is, you need to have a one high temperature reservoir, one low temperature reservoir. Okay, both should communicate with our invention. Whatever we are inventing, no, it should communicate. It gets something and it rejects something, and you get a net power output. This is possible. Now the question is how to minimize this as much as possible. Is a deal. That is the greatest of invention. From the day this statement came till now, there are millions and millions of inventions. All the innovations are aiming at one point. And nobody now will fund a project who say, I'll innovate this one. He'll be called stupid. And he will never get funding at all. Okay, so this is the one, in room in winter, if it is a very cold, what I'll do, I'll buy a machine called electric heater and give the electricity input. All the electricity will be converted into heat, I square R. There is no problem in that. You don't need another at all. So this is obvious. A common man does very cheaply. If I have a lot of mechanical power, lot of electric power, converting into heat is very easy. I can just have two things rubbing, and even this can do heating. That doesn't require anything. That is possible very much. The other option also possible. This is possible. This route is possible, and this route is impossible. And one should not waste at all any resources for this. Why Kelvin and Planck is saying that heat engine? Do you think thermodynamics is only to produce heat engines, anything else at all? But this is also true. It is the mother of the thermodynamics. That's why there is a website called Human Thermodynamics. You can visit by searching on the Google. Different people are using the second law, but basic second law was stated around the heat engine, because that is the mother of invention. So there are 160 statements of second law, each person, because he is not using always for a heat engine. Now the people started using a different statements other than the Kelvin Planck. Not only that, parallelly, almost little younger is inverse of heat engine. What is the inverse of heat engine? The inverse of heat engine is, I want to create an environment by consuming the mechanical work. I just want to create an environment, very clean, very warm, very cold, or depending on my requirement. I have produced a lot many fruits. These fruits I cannot sell now. I want to store them in a temperature so that their life will increase. Then what should I do? I have to control the temperature. I have to take out some heat so that these will not spoil. For that one, what you need to do? You need to develop an inverse of heat engine, and that's how they try to produce the another law which parallelly demanded. Go to the slide. Now you see this one. I am giving what is possible according to this statement. On the other side, it is obviously possible. All of you should think an inverse of second law. Is saying impossible. What is possible? I always miss this one in most of the books. Why do they end up in explaining the impossible statement? Before explaining the impossible statement, let us tell the students that what is possible, so that they can improve upon the possibility. Okay, on the other side, it is possible to construct a heat engine which produces no effect other than fraction of work from somebody converting into heat. That can be done. You don't need another reservoir to convert the work into heat. Or what is the other possibility he is talking about? The other statement which you will write on your own. The next important is about the creating the environment. The great Clausius, he said that there is a parallel demand on the food preservation, etc. In fact, no, once I was reading a article on 450 years of Vasco da Gama's visit or something. Then the statement no started with thing. If the refrigeration and air condition was invented well before, we wouldn't have lost the freedom at all. India wouldn't have lost the freedom. Why? If you see why all the Western people were hunting for the India, India is the country which was produced. They were in a bad need of, they don't know how to cultivate or how to develop. The initially they were searching for India only for spices. After coming here, they captured ourselves. In fact, if this technology has invented few hundred years before, India would have lost it. Maybe I'm telling for the fun, but I'm very serious that a technology not developed in a right time leads to a massive social impact. You believe me or not? Okay. So the finally, let us study the Clausius postulate. These are the called a postulate because nobody can approve. Heat cannot spontaneously from a region of low temperature to a region of high temperature. You need to place something. You need to help it. You need to aid it with the mechanical power or electrical power to have a heat transfer from low temperature to a high temperature. Have this entire room. I want this room to be uh, so we live happily. And outside is hotter. Now I need, I am talking about conditioning, and the should not stupidly think about innovating that no. So what is possible according to the Clausius? The law of nature. I told you the one fundamental law of nature is all the systems are if there is a system and surrounding, the law of nature says ki they want to come close to each other. They want to move towards the thermal equilibrium. One may be hot, one may be cold. The nature forces them naturally. No aid, no help. What is this one? This is the law of nature. So against this is unnatural. The heat can spontaneously pass from high temperature to low temperature. Nobody requires a help. In fact, no, to stop naturally, I tend to come to equilibrium. So these are the two things which are Kelvin Planck statement and the Clausius statement to contain the innovation. They want, see, thermodynamics is only one science which consciously thinks about economy of invention, expenditure on an invention. One should not foolishly waste their life on doing something impossible. Now the question is, what is the possible? How much is the possible? If this is impossible, how do we understand what is the possibility? Is it left open? Or is there anybody, oh, this is the maximum possible, theoretically, but you need to work hard. You need to invent a more and more ideas, then you can reach this goal. Such a great person who try to develop that. The best possible option is a reversible machine. If whatever a cycle you are developing, if you can establish that it is completely reversible, then people have to understand what is the meaning of reversibility. Again, more definitions, etc., which I will not. There are 5 slides on my website which talks about identification of reversibility. I'll not explain in general without explaining what is the irreversibility, reversibility. But Here, these are the standard things. Please go through my lecture notes where very important for this. The great Carnot gave an idea. 1824, this fellow came up with a cycle. Later, somebody invented what is called a Stirling cycle. And nobody is named after the third cycle, what is called a regenerate cycle. The first one, which says what is the best possibility, best cycle, or which can give the maximum efficiency. Because that's what I'm looking for, isn't it? Minimizing the heat loss. The next one was a Stirling, who invented this statement 60 years after this, if I remember correctly. I haven't given the date. And meanwhile, without anybody's name, they invented something called a regenerative cycle. I'll not explain these cycles because all the books explain very clearly what is a Carnot cycle, what is a Stirling cycle, what is the regenerative cycle. What is important now, all the cycles will give only one ultimate way of achieving the maximum performance. That is the beauty of the innovation. Okay, I have explained 2-3 slides how Carnot cycle starts the process of creating the best possibility. How he obtained a single point rule, very thumb rule, very easy thumb rule out of a lot many discussions. Unfortunate that we are not able to develop the machines exactly following this, but we are developing day by day. The most modern machine invented so far is more close to the Carnot cycle, very important, isn't it? The latest innovation is close to the oldest concept. Not we are not moving far. By doing a lot of research, we want to go back to 1824, 1824. Somehow we are not able to go back to the 1824. Something impractical in that. Lot many practical things have to develop to reach that Carnot cycle. But we are developing a lot. Day by day we are working hard. Because of that, we are saving the globe slowly. We became a conscious about the nature, whereas Carnot said the minimum least way of perturbing the nature. That is greatness of a Carnot. Okay. Again, I'm saying I'll not describe these cycles, getting an expression, which is a routine job. Almost all the books talk about this. I want to come up with the parallelism of various cycles. Okay. Again, skip around 30, 40, go to 100. No, or further. Can you skip more, please? Or there are many animations. Just further, further. All these slides are available on my website. Okay, I'll skip. Okay, so this is the greatness of the innovation. A cycle is always a control mass, I told you. There will be a constant mass flow rate, if not a constant mass, if they are control volumes. The first law says that how to design a cycle per unit mass. Okay, this is the one which I explained. Okay, so you can see this one, how the heat addition is changing, how the heat rejection is doing the jobs. Okay, I think I have to skip more. Or my next. Mm, I'll do that. Mm. So what is the greatness of thinking is, if you get a best idea, that best idea will have the only one. There are 3 ideas which are equally best, and all the best ideas will have the same kind of performance. And all the best ideas say how to get that maximum value. Okay, the first one is a Carnot engine, Carnot cycle 1824. After 60-70 years, Stirling engine. and much later or in between, there is no dating for a regenerative cycle. All these cycles will give a clue for what is the best possible innovation required. What is that best possible innovation? Well, is this. Okay. Okay. The algebra of these reversible missions which is done. This is the thing. Whatever may be the idea, it could be a Stirling's idea. You see how the Stirling cycle is constructed. What are the processes? All of you know the Carnot cycle has the two adiabatic processes, two isothermal processes. Both are supposed to be reversible in nature. And similarly, regenerative cycle also very funny way of constructing a reversible cycle. So suppose if you say my idea is the best, if there are 100 people who all say that our idea is the best, all best should be, there cannot be many best. There should be only one best, isn't it? So but there is no rule that a best idea has to be only one way. So very interesting in thermodynamics that there could be many ideas which are best, but all those ideas which are supposed to be best should have same performance. But to have a same performance, you cannot say that there is only one idea. Very interesting and important to this. So you can construct a Carnot cycle and get the best performance. Or you can construct a Stirling cycle, get the best performance. Or you can construct a regenerative cycle, you can get the best performance. Very important. There could be many best ideas. Why all these ideas are called the best? Because all of them have the same common sense. In fact, I personally believe that every religion is best. There can't be. Why? There are different paths. But all the religions are best because the ultimate growth is, ultimate is same. You have to be good, do good. That's all. So you cannot say this religion better than that religion. If one religion better than the other religion means you are doing something wrong with the better. So a religion has to be the best because you can achieve the best with different ways, and that best idea should be unique. The best objective should be unique. Sorry, best objective should be unique. What is the best objective? The great Carnot said, two more conquered this statement. The best possible efficiency means out of a given heat input, the maximum can be converted, the minimum that could be rejected. Both the ways, isn't it? I am giving both the formula. The first one is talking about the maximum I can convert. The second formula, the minimum, I need to minimize this fellow, isn't it? So the minimum this value, lesser will be the damage to the environment. And what is the clue? You go for any idea. There are 3 ideas which are proven. There could be 100 more ideas which can be proven. But all the ideas which are supposed to be best should be like this. What is the thing? You need to add the heat at the highest possible temperature. Wherever you are adding the heat, no, the heat addition should be done at a highest possible temperature. If you think there is a higher temperature possible, because of this reason I did not do. Because there is no material which can withstand, that's why I didn't do. Means you are not aiming for the best efficiency, you are aiming for the safety. You are aiming for the cheaper way of producing a machine, not the efficient machine production. At the same time, so whatever you are rejecting, no, it is impossible to stop the rejection. But it is possible to minimize the rejection. How do you minimize the rejection? Whenever you are ready for rejection, are you sure you could not create a temperature below this? Are you sure? How can you say that an IC engine rejects the heat at 450 degrees Celsius? How can you say that it is not possible? Recently, no, one of our colleague, Professor S.P. Singh, he arranged a kind of a conference or a get-together between the best automobile producers and the professors who are working in the automobiles, various ways. And there was a big meeting, one day of discussion, every professor came and said what I can do, what I am doing. Every manufacturer came, what we are doing, what we are looking forward. After the meeting, no, and there was a consolidation. And unanimously, all the automobile manufacturers wanted a solution from IIT Delhi professor who can do. What is that one? Can you believe how to use the waste heat out of the engine? Can you give me an idea? Because I don't want TL to be 450. I'll be very happy if the TL is actually ambient temperature, 30, 40, maybe at the most 50. Can you believe? All the automobile, and there are 10 more demands from the same group, but all those demands, no, two of them, three of them, four of them wanted, but all the entire group unanimously wanted one future solution. What is it? Can you decrease the exist temperature? You see the beauty of the statement stated by a boy of 24 years. 1824 is still the need of the day. All the manufacturers who are the giants, the Ford, you name the best companies were there in that meeting. Around 25 people, 25 different representatives, and all wanted unanimously one. Why? So how do you implement Carnot's idea? Through different route. Why? The route suggested by the Carnot is impractical somehow. Okay. So using a generalized indices, I'm using this particular one. You see this one? I'm using this statement. What I want QLTR to be minimum. And how to do it? Yes, you can do it only when the T of temperature of the low temperature reservoir bare minimum. That's all. The cause effect. If I want this effect, you should create a cause like this. If you can get an idea which will decrease the temperature of the condenser, which can decrease the temperature of the exhaust gas, then you can minimize the QLTR. The effect, what causes this effect is known. But how to make this cause coming, how to achieve this effect is still unknown. We are not through. Even then, as long as all the automobile engines produce exhaust gas temperature more than 50, the research is not complete. The idea is not perfect. All those ideas, it could be Ford or Mercedes-Benz or anybody, they are not the best. Why? Because though the routes are different, they haven't reached the same, that ultimate same. People have to work hard. People have to innovate. So that's why, what is the objective of innovation? Can I do some algebra? What I'm supposed to do while innovating? How to create this cause? Unless I know more fundamental, this cause cannot happen. You see, I'm doing an algebra because both are 1 minus 1 minus, see, 1 minus something, 1 minus something. So I'm taking this minus part equating, isn't it? So explicitly it shows that the ratio of value, magnitude of heat rejection to heat input should be identically equal to the ratio of the temperature of the low dump or a sink, the temperature of divided by the temperature of this one. This is the achieving. So the effect and cause, no, they should be in proportion. Unless you produce a cause which is in proportion to the required effect, you will not do the best. So you are aiming for something and you are causing little. How ridiculous this. If your TLTR is more than the required, obviously QLTR will be more. Okay, so this is the where the people wanted to do research, wanted to understand the bottom line of innovation, the prediction. How to do? Then you see the algebra. How powerful is the algebra to create? Suppose if I run a cycle for a time t, I want to know the integral effect. Then I can write this particular one. So this is the instantaneous, no? The rate of heat rejection by the temperature of the rejector, the rate of heat input divided by the temperature of the input device. I want to integrate for a time tau. If I integrate for a time tau, I can get this one. Okay. So what is the total heat lost in a time 10 seconds and what is the temperature of that reservoir? If the temperature changes with the time, then you are not doing a good job. When can you do a perfect job? You achieve the lowest temperature. That lowest temperature cannot decrease or increase with the time. Then you cannot say you have created a lowest temperature. Are you getting my point? That's why the great Carnot said that heat input should be at a constant temperature. The heat rejection should be at a constant temperature. When the temperature is constant, then only you can say I have achieved the lowest temperature at rejection. If it varies with the time, how can you say you have created the lowest? Similarly, whenever you are adding the heat, If the temperature is the highest, then only you can say I have created. When will the highest be highest? It should be highest value and constant. So the great idea why Carnot wanted heat input and heat rejection, unless you achieve it a isothermal, you cannot get the best deal. Why? Unless the temperature is not constant, how can I say I have achieved the highest? If the temperature varies with the time, obviously minimum to maximum or maximum to minimum. So during this time, you haven't achieved the minimum, some average value. This average value is lower than the higher one, higher than the lower one. So you haven't done the job at all. That's why the great Carnot, as a boy, he said that if somebody can develop a device, if all the heat addition happens at a constant temperature, then in future I can innovate how to increase that constant temperature of heat addition by inventing a new material, new process, new fuel. But first you should know to keep it constant. Similarly, if I reject all the heat at a constant temperature, if I develop a device like that, with time now I can innovate how to decrease this value. There are two things in innovating the perfect. First one is you should try to produce such an idea which doesn't change the temperature during the heat addition or heat rejection. That is number one. The moment you do know that you will get an idea, maybe take the 10 years, 15 years or 20 years, but you are sure the moment you know how to keep the temperature constant during heat addition, the temperature constant during the heat rejection, then you will essentially move towards increasing that high temperature, decreasing this low temperature. If you cannot do, then there is a problem. If the temperature itself is varying during the heat addition, how can you achieve the highest or the lowest? It's only the misconception. So that root, the one root essentially is first try to achieve a constant temperature. Why it is impractical? How to make it practical? How many systems are required? How many volumes are required? Is the idea of research. People are coming with hundreds of ideas. When you do that one, no, this is what is going to happen because the heat rejection is negative, heat input is positive. All of you know this sign. First, initially I am taking the modulus of heat rejection. Now if I drop the modulus, minus of minus will become a plus. Now you see this one, some quantity for a cycle is becoming zero. Very funny, you know. Algebra gives very integral idea. For any reversible cycle with n number of heat transfers, n number of work transfers, because the cycle cannot talk about two processes only, one heat rejection, one heat input. But I can innovate a cycle which has 100 transfers, input, 100 rejections if I wish, that's all. It is a matter of visualization, then I can say that. The algebraic sum of the amount of heat transferred to the temperature at which you are doing a heat transfer. This is the important aspect of it. Not able to achieve a constant temperature during a heat transfer is the biggest drawback in innovation. Everybody should strive to. Suppose if the temperature is varying, no, that mean value should be highest. When will the mean will be close and the minima and maximum move together, then the average will be better. If the minimum is very low and maximum is very high during a heat transfer, the average will be very poor. All your efforts are useless. See the great ideas in a simple formula. In fact, now if I spend 20 hours discussing this particular one, I still think that I have done the justification. One statement has infinite amount of knowledge for creation. So where I shows the ith process and n is the number of process in a cycle. Okay, so that's how, because it is a cycle, but q is a path function depend on the process, isn't it? 1 to 2. The q is a effect of entire thing from 1 to 2. This 1 to 2 I have one temperature. 2 to 3 another heat transfer. This entire 2 to 3 there is another temperature. 3 to 4 I am not asking 1 to 2, 2 to 3, 3 to 4 same temperature, not required at all. But 1 to 2 have a one temperature, which means that there is some amount of uh, dividing the heat transfer. Instead of dumping all the heat transfer, you try to divide the heat transfer process. That's why in a modern steam power plant, no, there is an economizer, some heat addition, there is a boiler, some heat addition, there is a superheater. Within the superheater, no, they will have a low temperature superheater, intermediate temperature superheater, high temperature superheater. They redistribute. Why? if you redistribute, you can try to achieve some possibility of uniform temperature maybe. Okay, so this is the reversible cycles talk about. All the reversible cycles say that the cyclic integral of del q by t is 0. Whatever may be the number of processes. Okay, the k is an initial state, k plus 1 is the final state. I have m number of processes going through. Okay, so you can see this one. M is the number of state points in a cycle. 1 to 2, 2 to 3, 3 to 4, 4 to 5. And the last one is same as the first one, of course. N plus 1 is equal to 1. Therefore, for all reversible cycles, what is good? This is the one. Now, again coming to the definition of the property. During a cycle, any variable unknown remains constant means that should be a property. So what the Carnot is trying to give to the whole world that whatever heat transfer you are doing, whatever heat rejection you are doing, no, that should lead to one particular property controlled. What is that property which is controlled? It is the ratio of del Q by T. The cyclic integral of this is remaining 0. If you can try to control consciously this particular new property, which is impossible to feel by hand, that is the unfortunate thing. My senses cannot feel this one. I can feel the pressure, I can feel the temperature, I can feel the volume. All those things I immediately declared as a properties. But this particular algebra is giving a property which is essential for doing the best, and I don't feel, unfortunately. And people know philosophically because they did not feel, they did not respect. Very unfortunate thing, no? I always feel that this is the respect. Uh, one question is, in an air standard cycle, the efficiency depends on the compression ratio. Why? Because higher the compression ratio, you can create the highest temperature with the same amount of fuel burned. That is the beauty of this. If you have a less compression ratio, you are burning the same amount of fuel, but your highest temperature is lower. Very interesting. So in a air standard cycle, the economic way of achieving the highest temperature is to increase the compression ratio. Or in a Brayton cycle, increase the pressure ratio. Beauty is see. The Carnot says that achieving the goal need not be one. So means it looks like if you increase the compression ratio in an Otto cycle or a diesel cycle, or you increase the pressure ratio in a Brayton cycle, you can achieve highest temperature of heat addition very easily. And hence that will fetch you the good efficiency. But you should teach the student that because I am not able to practically achieve a Carnot cycle, what I could practically achieve is a Otto cycle, diesel cycle or a Brayton cycle, but Carnot's idea, no, I am following. I'm not violating the Carnot idea. How to follow the Carnot's idea? Only by increasing the compression ratio. All of you see, higher the compression ratio, higher the pressure ratio, the start temperature of the heat addition will be very large. If the starting of heat addition is very large, ending of heat addition will be very large. If both are large, the mean will be large and hence better efficiency. You will be very careful. I said it, no, the religion is never a unique, but reaching the destiny, understanding the spiritual is only one. So whether you change the compression ratio to achieve the highest temperature, or you change the pressure ratio for that, or you do something else to reach that, that is all religion. As good as so many religions making people happy, there are so many processes which will make happy. And I'll be very happy if there are more religions invented in future. Perhaps they may be better. There may be, sorry, they may also give a clarity. So that's how the way we innovate a more cycles in future. Okay, this cyclic integral 0. Okay, the cyclic integral of this new quantity is 0. This new quantity, which is called and which was floating in the air. The people thought it is a philosophy, it cannot be quantified. It is not an engineering parameter, it is a psychology parameter. It is a state of mind. If your state of mind is good, you will think positively. If the state of mind is bad, that state of mind, they use a word called entropy. Entropy is a kind of order disorder. If you are well focused, meditate, your entropy will be very small because your thinking process is not scattered. So that's how the entropy was used. The people thought entropy is a philosophical word or a psychological word that cannot given a number. But if you think carefully, you can give a number. The great Boltzmann created a numerical value to the entropy. Otherwise, before that, entropy was used in very vaguely, very philosophically. Entropy is not a new word. Entropy started with the human philosophy, human thinking. And they invented this word very early, but they thought this can never be. The delta Q by 2 is independent of path for a reversible process. And this is the one, how economically you are creating. Whenever you are doing a thing, that thing should be done perfect way. So for a reversible process, infinitesimal change in property is the ds, del Q by T. Only for reversible it is defined, how to calculate, etc. So the Boltzmann named S as an entropy of a substance. Okay, in order to calculate the value, you should do a reversible process, then you can calculate. But entropy will prevail. Whether it's a reversible or irreversible, entropy will prevail. That is not the idea. So if you want to calculate the value of entropy, what is happening, or to give a numbers to the entropy, the way, no, how do you calculate the change in internal energy? Do a constant volume heat addition. That is the easiest way. How do you calculate the change in enthalpy? All of you know. Do a constant pressure heat addition. It doesn't mean that enthalpy will change only when there is a constant pressure heat addition. That is stupid. Enthalpy can change because of many things. But whenever I am laboratory definition, no, I will be very happy how to precisely define enthalpy. This is also, entropy is defined as this one, but entropy will change because it's the universal nature of the entire world. Okay, during a reversible process, the change in entropy is independent of path, and the final entropy and initial entropy is the one which is going through. Okay, so the entropy, a measure of state of everybody, whether I'm happy, whether I'm stressed, whether I'm enjoying or whether I'm not enjoying. I'm standing in front of you, and am I enjoying whatever I'm saying, or whether I'm not enjoying will be easily seen by many of the features, which could be number with an entropy perhaps. Okay, that is the state of mind. You see this one, I have the same molecules. Inside the molecules, same atoms. Inside the atoms, same neutrons, protons, electrons, etc. But how they are arranged will decide their state of mind. You see this one, if it is a solid of any substance, beautiful organization. When it is a liquid, little randomness. When it is a vapor, much more random. That's how the entropy, suppose if I can create at a triple point, if I see, at a triple point now I can get the solid, liquid, vapor. All, isn't it? If I move a little liquid side, little solid side, a little vapor side, you can see this one. For a given substance, this is the law of nature. Why? The solid organizes very nicely. The gases are extremely random. Okay? The beauty of this one, whenever you are changing a state from one to other, means you are creating entropy because you are moving from a low to high or a high to low. Okay? You see this one? Suppose if I take the water at the same temperature, maybe 100 degrees Celsius, or because for every pressure there is a saturation temperature, no? You can have a liquid and vapor. They are in equilibrium. And I am heating the water, boiling the water. During the boiling process, there is some water, some vapor. Both are at a same temperature, same pressure, but um, steam molecules are random, liquid molecules are little organized. Why and how? This is the entropy gives the state of everything. You see this one, if you want to create a random state from a order state, okay? So I'm giving the examples, you see. This is a bromine. So the liquid bromine will have a less entropy than the bromine gas. Now you see this one. I have a ice and water mixture. If I see the ice structure, see H2O is so nicely packed. The same thing when it is a water, no doubt both are H2O. All of you know solid has a less entropy than the liquid water. Why? Organization. And this is the organization is the one. see the great, uh, uh, Carnot saying that whenever you burn something, whenever you add the heat, no doubt you are creating a randomness. But be conscious, you should create the heat transfer with a minimum randomness. When will that happen? If you can do the entire heat transfer at the highest temperature, because everybody demands some heat transfer, isn't it? So I'm demanding some heat transfer. If that heat addition occurs at highest temperature, see del Q by T, minimum randomness creation. In the same way, whenever I'm rejecting a heat, then you need to be lowest entropy creation appropriately. This is the greatness of the entire thing. Increase in molecular complexity in generally leads to the increase in entropy. Okay, I'll just close. Oh, okay. So I'll just continue because I want to get a picture. Entropy existed on this globe, various things, millions and millions of, I think, I can't say millions years, few hundred decades people were floating this word. Everybody used it as a descriptive philosophical word. But thermodynamics is great because one of the most powerful word was quantified. Why? Why quantification is, again, the Kelvin said, when you give a number to your understanding, you know something. If you are not able to number know, your understanding is of not much. You can always say two people arguing without a number, the one who talks more will win. If it is a number, both should come to the same thing. After all, it is a number. Okay. Now you see the beauty of this. Suppose if I have a solid, if I go on heating, the entropy increases slowly. But there is a critical point the structure cannot handle. If you want to add more heat, it is essential to create a tremendous increase in disorder. Afterwards, again there is a caliber. So you can add more and more heat by increasing the entropy slowly. But again, there is a thing. So there is a big increase. Afterwards, for an infinite temperature, it will happen smoothly. You don't have to create that abrupt. So this is the beauty of the gas. The gas, no, once you reach a gaseous state, the creation of disorder is always monotonic, slow, continuous. You will not get any kind of interruption now. So that's how whenever you want to add a heat or anything, deal with the vapor. During your process, you're not going to commit a blunders of thing. Suppose if you start with a liquid and then go on, then it is essential that you make a kind of blunder. The people wanted to avoid, what can I do to avoid this? That's where you know the critical point. So as a last slide, I'm trying to project this one. S increases continuously slightly with the temperature once it is a vapor. Okay, but there is an abrupt increase. Why? Organization is changing. As a solid, more the heat input, more amplitude of vibration, but the organization is same, and that cannot be continued forever. Suddenly there is a critical temperature where you need to reorganize, break, then randomness. So the beauty of this one, see this one, the simple boy of 24 years, how could he think that whenever you are burning a fuel, you are creating a disorder? But be conscious that you create a least disorder to get your thing. If I am not conscious, what will happen? I'll burn more fuel than the required, then create global warming and the scarcity both. If I'm conscious, I need power, I need some heat, but am I sure that I have created this need with the minimum entropy? If yes, then you are happy. That is the best solution. If not, you should strive for the betterment. So please derive the entropy and try to understand how entropy changes with each process. That's how you will understand what is the best process while adding the heat to create the minimum entropy. So all those things are essential. If you create a more disorder, you will get a less payment or a less enjoyment. Thank you, and read more slides on my website. And you should understand how to learn or how to teach rather than everything from one person is ridiculous, because I may not be knowing everything at all, but at least you should know the level of understanding, the style of understanding, the style of teaching. This will help you in learning more in your future. Thank you. Thanks for listening to me so many hours, and be happy. Visit my website for more courses in future. I have quite a few, and more will be added. Thank you. Thank you very much.